explorers are sending back alarming data to Earth. The Explorer 1, NASA's farthest journeyed rocket, is still bridging uncovered regions of the universe right around 50 years after its launch. Specialists are baffled by the surprising information this notable space probe is sending back to Earth due to what appears to be a malfunction. Join us as we examine the unusual data that the Explorer has been transmitting during its delicate space exploration adventure. Analysts have been captivated by studying the area beyond since the Big Bang, which inspired the launch of Explorer 1 and Explorer 2, among other space missions. Explorer 2 was actually the first spacecraft to launch, departing from NASA's Kennedy Space Center on August 2, 1977. On September 5th of the same year, Explorer 1 was launched roughly 2 weeks later. However, how did they switch places? As twins, the weight of both probes is around 720 kilograms, comparable to a small car. They were launched during a window of exceptional outer planet alignments that created a slingshot effect, enabling the spacecraft to travel from one planet to another. However, they needed to move at different speeds and in different directions. On December 15, 1977, Explorer 1 managed to pass its identical twin en route, and from then on, it became our go-to resource for learning about space-related mysteries. The first spacecraft to do so, it began its Jovian imaging mission in 1978. At that time, it was nearly 265 million kilometers from Earth and transmitted a massive number of photos back. Explorer 1 completed an extraordinary 108-hour stretch starting in January 1979, during which it captured 3,750 images of Jupiter's rotation to produce a time-lapse film showing 10 rotations of the planet. It passed through the Jovian moon system in February 1979, and a month later, it discovered a faint ring surrounding Jupiter. Explorer 1 also made a groundbreaking discovery when it identified 2 new moons, named F and Neos. Careful planning was undertaken to ensure the spacecraft was prepared for its Saturn flyby and to prevent potential collisions with Titan, one of Saturn's moons. Explorer 1 also discovered 4 additional moons during its orbit of Saturn: Mimas, Enceladus, Tethys, and Dione. Researchers chose to end the Pioneer planetary mission after the Saturn mission and sent both Explorer 1 and Explorer 2 beyond our planetary system at a speed of 325 million kilometers per year. In January 1990, the new mission, previously known as the Voyager interstellar mission, began. Some of the most iconic photos in history, depicting the Sun and most of the planets, were taken by Explorer 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. These are commonly referred to as the Solar System Family Portrait. A total of 60 images were taken by Explorer 1, bringing the total number of photos captured by the spacecraft to 670. Despite the fact that Mercury and Mars could not be seen in the photos due to various factors, the spacecraft's cameras were powered down to conserve energy and memory before its journey into interstellar space. In addition to the interstellar explorers, NASA also operates Pioneer 10, Pioneer 11, and the New Horizons spacecraft. Before Explorer 1 surpassed Pioneer 10 on February 17, 1998, Pioneer 10 held the title of the farthest spacecraft. Explorer 1 continued its journey for another 14 years before it finally entered the interstellar environment on August 25, 2012. NASA publicly announced the milestone in 2013. By November 2018, both spacecraft had officially left the nearby planetary system, with Explorer 2 crossing the heliopause into the interstellar medium. Explorer 1 is estimated to be 145 billion miles, 550 million kilometers from Earth. It continues to provide groundbreaking data that no other space missions have been able to uncover. However, recent anomalies in its performance have left scientists puzzled. Explorer 1 is currently transmitting astounding signals back to Earth, suggesting that it may be uncertain of its location coordinates. Surprisingly, the spacecraft has not entered safe mode or triggered alerts, as it typically would when encountering issues. Its antenna, which transmits data back to Earth, appears to be functioning perfectly. Yet the information recently transmitted shows inconsistencies. While the interstellar traveler is operating normally, following commands from Earth and gathering data. The readouts from its attitude and control system do not accurately reflect its actual condition. According to a NASA statement, what is happening aboard Explorer 1 remains unclear. Each spacecraft heading toward interstellar space, including Explorers 1 and 2, carries a 12-inch wide gold-plated disk. This disk contains audio and video messages as a backup in case an alien species finds the probe. It includes 35 Earth sounds, 115 images, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter and former UN Secretary General Kurt Waldheim. These messages are recorded in 55 different languages. While some speculate that the spacecraft might be under alien control, experts have quickly dismissed this theory. Explorer 1's functionality heavily depends on its attitude and control system, which continuously keeps its antenna focused on Earth to ensure accurate data transmission. Engineers monitoring the situation believe the system is working as expected, adding to the mystery. None of the safety mechanisms designed to protect the spacecraft have been activated. According to Susan Dodd, project manager for Explorer 1, this mystery is not entirely negative. She noted that the spacecraft is over 45 years old, much older than originally planned. Dodd acknowledges that addressing the issue with Explorer 1 will pose significant challenges for its engineering team due to its vast distance from Earth. Explorer 1's current predicament highlights the resilience and ingenuity of the spacecraft's design, which has far exceeded its original mission objectives. The data it continues to send back offers invaluable insights into the interstellar environment, a region of space that remains largely unexplored. Despite its age, Explorer 1 has managed to maintain communication with Earth, thanks to its robust power systems and well-crafted engineering. However, the anomalies observed in its data transmissions have raised questions about the spacecraft's internal systems. NASA scientists are now focused on analyzing these inconsistencies to determine whether they are caused by environmental factors in interstellar space, degradation of onboard components, or a previously unknown phenomenon. One potential explanation for the anomalies could be related to cosmic radiation. As Explorer 1 traverses deeper into interstellar space, it encounters higher levels of radiation that may interfere with its systems. Another possibility is that the spacecraft's aging components, such as its onboard gyroscopes or attitude control mechanisms, may be gradually deteriorating after decades of exposure to extreme conditions. To address these challenges, NASA engineers are working to reprogram the spacecraft remotely, optimizing its systems to extend its operational lifespan. However, the sheer distance of Explorer 1, over 20 light hours away from Earth, means that every command sent takes nearly a full day to reach the probe. This delay makes troubleshooting a slow and complex process. Meanwhile, Explorer 2, the spacecraft's twin, continues its journey through interstellar space, providing complementary data to that of Explorer 1. Together, the two probes are helping scientists map the boundaries of our solar system and understand the transition into interstellar space. Both spacecraft have encountered the heliopause, the boundary where the sun's influence ends and interstellar space begins. This region is marked by a sudden drop in solar wind particles and an increase in cosmic rays. The data collected by Explorers 1 and 2 at the heliopause has provided groundbreaking insights into the structure and dynamics of our solar system's outermost frontier. Despite the uncertainties surrounding Explorer 1, its contributions to science remain unparalleled. The spacecraft has not only advanced our understanding of the cosmos, but also inspired generations of scientists and engineers. As NASA continues to monitor and study the anomalies, Explorer 1 stands as a testament to humanity's ability to explore the unknown and push the boundaries of what is possible. The mission, initially designed to last only a few years, has become one of the longest-running and most successful in NASA's history. As Explorer 1 and its twin continue their silent voyage through the cosmos, they carry with them the hopes and aspirations of a species determined to understand its place in the universe. Us and the space apparatus. The difficulties are gigantic, to a great extent because of the rocket being around 145 billion miles from Earth. This huge distance presents various burdens that the group must explore cautiously. A salvage activity is almost unthinkable given the current innovative and key limitations. Explorer 1 is far beyond the scope of any space apparatus or repair mission that we could reasonably send. The space apparatus' astonishing journey has carried it into the farthest areas of our nearby planetary gathering and beyond, into interstellar space, where it continues to travel further away from us consistently. Messages sent from Earth at the speed of light take almost 21 hours to reach Explorer 1's current location. This means that any request or guidance sent by the engineering team takes significant time to be received by the spacecraft. This delay represents a huge challenge for ongoing troubleshooting and examination. Moreover, once Explorer 1 processes the request, any response or data it sends back to Earth will require an additional 21 hours to return. This suggests that two-way communication between Earth and the space apparatus takes an average of 2 days. Such a delay makes it particularly challenging to carry out practical solutions or iterative troubleshooting processes, which are often essential when dealing with complex technical issues. The engineering team must carefully plan and execute each command, anticipating various scenarios and potential outcomes. Unlike missions closer to Earth, where experts can quickly send and receive orders, the long communication delay requires a more strategic and patient approach. Every instruction must be meticulously designed to address the known issues without causing additional problems, given the extended time it takes to confirm whether the command had the desired effect. The critical communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be successful and precise, leaving little margin for error. This requires extensive testing and validation of commands on Earth before they are sent to Explorer 1. In addition to these strategic challenges, the spacecraft itself is over 40 years old, having been launched in 1977. The technology on board, cutting edge at the time, is now considered obsolete by modern standards. The engineering team must work with hardware and systems that were designed and built during the 1970s, adding another layer of complexity to the problem-solving process. The harsh environment of space has also caused significant wear and tear on the spacecraft systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, the engineering team remains committed to resolving the ongoing issues. They are exploring different theories about what might be causing the anomalies and testing potential solutions through simulations on Earth. This careful, deliberate approach is crucial given the stakes involved. Any incorrect command could potentially worsen the situation or lead to a loss of communication with the spacecraft. The team is also leveraging the redundancy built into Explorer 1 systems. Like many other space missions, Explorer 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems and restore normal operations if they confirm that a specific component is failing. In summary, while the challenges of diagnosing and fixing the issues with Explorer 1 are immense, the engineering team is utilizing their expertise, experience, and the spacecraft's inherent resilience to address the problems. Their careful and patient approach is essential in managing the critical communication delay and the complexities of working with a spacecraft that is both extremely distant and fully aged. Despite the odds, their efforts aim to continue Explorer 1's legacy of exploration and scientific discovery far beyond its original mission limits. The malfunctions may be the result of cosmic rays altering some of the spacecraft's delicate electrical systems. These high-energy particles, originating from distant supernovae or cosmic events, travel through space at nearly the speed of light. When they strike Explorer 1, the particles can penetrate its exterior and affect internal electronic components. The longer the spacecraft remains in space, the greater the likelihood that cosmic rays will affect its systems over time. This phenomenon can lead to irregular anomalies like the ones currently observed in Explorer 1's telemetry data. Engineers have long been aware of the potential risks of cosmic rays to spacecraft electronics and even human travelers. However, the extent of their impact can be challenging to predict or mitigate. Despite these challenges, engineers have implemented various measures to protect spacecraft from cosmic rays, including shielding sensitive electronics, designing redundant systems, and using error-correcting codes in data transmission. Even with these safeguards, cosmic rays can still pose a threat, especially to spacecraft operating in deep space for extended periods, as in the case of Explorer 1. Although the current anomalies in Explorer 1's data are perplexing, they are not entirely unexpected given the spacecraft's age and prolonged exposure to cosmic rays. Engineers and scientists continue to monitor the situation and analyze the data received from Explorer 1. They are working to determine the exact cause of the anomalies and develop strategies to mitigate their effects on the spacecraft's operations. Despite these difficulties, Explorer 1 has far exceeded its original mission expectations and continues to provide valuable insights into the outer regions of our planetary system and beyond. Its accomplishments are a testament to the ingenuity of its creators and the dedication of the team that has supported it for over 40 years. The engineering team's work on Explorer 1 exemplifies the resilience required to manage a spacecraft operating in conditions vastly different from those closer to Earth. The issues currently faced underscore the broader challenges of long-duration missions in deep space. These challenges are not unique to Explorer 1, but represent a growing concern for future missions aiming to explore the outer planets, interstellar space, and beyond. One critical area of focus for the team is the spacecraft's power systems. After over 4 decades of continuous operation, Explorer 1's power supply is no longer as reliable as it once was. Its onboard power source, originally designed to last for only a few years, has managed to sustain the spacecraft far beyond its intended operational life. However, the gradual decline in power output necessitates careful prioritization of which systems to keep operational. Engineers must make difficult decisions, balancing scientific objectives with the need to preserve the spacecraft's overall functionality. Another major challenge is the degradation of the spacecraft's communication systems. As the distance between Explorer 1 and Earth continues to grow, the signals it sends back become increasingly faint. The Deep Space Network, DSN, a global system of antennas used to communicate with distant spacecraft, plays a vital role in maintaining contact. However, as the spacecraft's transmitter weakens over time, receiving and interpreting its data becomes more difficult. The engineering team must rely on sophisticated algorithms and signal processing techniques to extract meaningful information from the faint transmissions. Despite these hurdles, Explorer 1 continues to deliver valuable scientific data. Its instruments, though aged, still provide insights into the conditions of interstellar space. The spacecraft's observations of cosmic rays, magnetic fields, and other phenomena are helping scientists refine their understanding of the space environment beyond our solar system. These findings contribute to our broader knowledge of the universe and inform the design of future missions. The ongoing success of Explorer 1 is also a testament to the foresight of its original designers. By incorporating redundancy, robust materials, and adaptable systems, they created a spacecraft capable of enduring the rigors of space for decades. This legacy of thoughtful engineering serves as a blueprint for future deep space missions, emphasizing the importance of planning for longevity and adaptability in the face of the unknown. Looking ahead, the lessons learned from Explorer 1's challenges and triumphs will be invaluable as humanity embarks on even more ambitious endeavors. Missions like the James Webb Space Telescope, the Europa Clipper, and future interstellar probes will face similar issues of distance, communication delays, and environmental hazards. The expertise gained from maintaining and operating Explorer 1 will inform the strategies used to ensure the success of these cutting-edge missions. Explorer 1's remarkable journey serves as a powerful reminder of the potential of human ingenuity and perseverance. While the spacecraft itself may one day cease to function, its legacy will endure, inspiring generations of scientists, engineers, and dreamers to push the boundaries of exploration. As it travels ever farther into the cosmos, Explorer 1 remains a symbol of our relentless pursuit of knowledge and our enduring connection to the universe.